Here's some notes on graphing linear equations using a function table. We know that linear equations make a line. So the most basic method is to pick coordinates for the x, substitute them into your equation or function, solve for y, and then you'll have x and y coordinates for your ordered pair. Plot the point, do that for two other points, and if they line up, they make a line. Now, what we're going to also do during this lesson is I'm going to give you clues as to how we can make this easier so that we can progress into graphing linear equations using slope-intercept form, using quick graphs like y, the x and y intercepts. Okay, so let's start out here. Okay, we know this is going to be our x column. Here's our function, 3x minus 4. Here's our y column, and here's our ordered pair column. So we can pick the points we want for the x. So I'm going to pick 0, 1, and 2. I don't really want negatives, but I want a 0 there. Okay? And in a minute, we'll show you why. So now we substitute 0 in for that x each time. So I have 3 times 0 minus 4. Then I'm going to have 3 times 1 minus 4. And then I'm going to have 3 times 2 minus 4. Okay? So I have 0 minus 4 is negative 4. 3 minus 4 is negative 1. 6 minus 4 is 2. What I want you to notice right now is when I have a pattern over here with my x coordinates, plus 1, I'm going to have a pattern with my y. Okay, negative 4 to negative 1 is adding 3. Negative 1 to 2 is adding 3. What I want you to notice is now this pattern right here ends up being this number in front if our pattern for our x coordinates is adding 1. And then we actually call that slope then, or rate of change. How far up, how far over. Okay, so now we can go ahead and graph. So I have 0, negative 4. So that's left to right, nothing, and then down 4. Okay, then I have 1, negative 1. So that's over 1 and down 1. And then I have 2, 2, which is over 2 and up 2. Sure looks like that makes a line, so we use a straight edge. Okay. Now I want you to notice something else that's going to help us later. Notice this point right here. It's on the line. Well, the actual coordinates are 0, 4. We call this the y-intercept. It's where a line crosses the y-axis. Well, if you notice, that x is 0. That's why I chose it over here. So whenever x is 0, we're given the y-intercept. Now notice something about that in the equation. Negative 4, negative 4. We just actually demonstrated slope-intercept form, which is y equals mx plus b. M is your slope, b is your y-intercept. We're going to use this later to graph equations without the table. Okay, next one. All right, we have our x column. We know we're going to use 1, 2, 0, 1, and 2. Here's our function, negative 2x plus 4. Here's our y column, and here's our ordered pair column. Okay, so let's substitute. So we have negative 2 times 0 plus 4, negative 2 times 1 plus 4, negative 2 times 2 plus 4. Okay, do your order of operations. That's 0 plus 4. That's negative 2 plus 4, which is 2. And that's negative 4 plus 4, which is 0. Again, point out that our pattern here for our x's is adding 1. So whenever that's the case, our pattern in our y's is going to be our slope, or m. So notice, there it is. It's the number in front of the x. Okay, our ordered pairs are 0, 4, 1, 2, and 2, 0. So now let's go ahead and plot them. We know when x is 0 that that's our y-intercept, and we knew that from before because there it was right there, positive 4. Okay, our next point is 1, 2, so over 1 and up 2. And our next point is 2, 0. So over 2, oh, I must have made a mistake somewhere. 0 plus 4 is 0, 4. Negative 2, it's, oh, I see where I made a mistake. I should have seen that before. Okay. 0, 4 is up here. Notice that I wasn't making a line. Then my 1, 2, then my 2, 0. And I should have noticed that because when I said 0, 4, that was there, but I was down here at negative 4. So there's my line. Go ahead and graph it. And the equation y equals negative 2x plus 4 is now written, or is now shown graphically. Okay, next one. So here's our x. I'm going to use black for that. Okay, we're going to again choose a point 0, 1, and 2. Here's our function, x minus 3. Here's our y coordinates. Here's our ordered pair. So I have basically 0 minus 3. Then I'm going to have 1 minus 3. And then 2 minus 3. If it helps you, go ahead and remember to do your same change switch if you want, like we did when solving equations. So that's going to be negative 3. That's going to be negative 2. That's going to be negative 1. So again, our pattern when we're adding 1 for our x's will give us a pattern for our y's, and that pattern is our slope. Plus 1, that would actually be the 1 that's in front if we wanted to write it. Okay, we know right off the bat that if I did same change opposites here, negative 3 is going to be our y-intercept, and there it is. When x is 0, there's our y-intercept. So if we plot our points, 0, negative 3, we can go right to our y-intercept from the start. Our next point is 1, negative 2. That's over 1 down 2. And then our next point is 2, negative 1. So over 2 down 1. And there we have a graph of our equation. Okay? All right, so x, 0, 1, 2. Here's our function, y-coordinates, ordered pairs. Now that negative means I'm going to have a negative, and then the 0 is inside. So again, negative, and then the 1's inside, and then negative, and then the 2 is substituted inside. Okay? Again, if you have trouble, go ahead and do your same change switch. So I have 0 plus negative 2 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 2 plus negative 2 is negative 4. So here's my pattern of adding 1. So this pattern here of subtracting 1, because as I get smaller in the negatives and subtracting, demonstrate that there's my negative, and we could put a 1 in front. That's our slope. If I go ahead and do same change opposites here, we know that's our y-intercept. So even instead of using this ordered pair, I simply know I'm going to go to the point on the y-axis where it's negative 2, and I can plot my point. And that's that point right there. Then I have 1, negative 3, so over 1 down 3. And then I have 2, negative 4, so over 2 down 4. And I have my line. Kind of interesting, whenever we have a 1 or negative 1 in front of our x, it's actually going to make a 45-degree angle. It's going to cut these little boxes exactly in half from that are vertex to vertex. Okay, next one. Okay, our x, again, choose 0, 1, 2. Remember, you can choose whatever you want. I'm just telling you those are pretty easy to use. Then our y, then our ordered pair. Okay. So I'm going to have 2 times 0 plus 1, then 2 times 1 plus 1, then 2 times 2 plus 1. Okay, 0 plus 1 is 1, 2 plus 1 is 3, 4 plus 1 is 5. So our ordered pairs are 0, 1, 1, 3, and 2, 5. All right, what I'm going to show you right now is if we continually do our function table, it's going to take too long. So we want to graduate to an easier way of doing something. In the real world, if you can demonstrate you're more efficient and faster than somebody else, you're going to get the job, you're going to get the promotion, you're going to make more money. So remember how we said at the very beginning, if we can show our equation in slope-intercept form, this number in front is called our slope. This number in front is our y-intercept. Remember, our y-intercept is always a point on the graph. I need 2 points to make a line. All right, we know this is our y-intercept, plus 1. So that means if I go to my graph and I go on the y-axis at 1, there is my point. And obviously, we could have gotten it from the table too. Now, how do we get our second point? Well, slope is rate of change. It's like walking up steps at your house. Up and over, up and over, up and over. So we know our slope is 2 or 2 over 1. This is our rise going up. This is our run going left and right. So watch how I do this. I'm going to go up 2, and since it's positive, over 1. Up 2 over 1. And I can keep doing that, same slope. So now when I draw my line, looks like this. So we won't need to use the function table if we can use slope-intercept form. Okay? Now if we go back just to prove our point, here's 1, 3, and there it was. Here's 2, 5, and there it was. So it's just a different way of doing it. All right, hopefully that helps you, and we'll discuss more of this later.